Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing multiplicity and graphing polynomial functions. So in the last lecture we discussed how to graph polynomial functions in general, but we bypassed talking about multiplicity. So and in previous sections in 4.1 we talked about what multiplicity was, at least how to find the number. And I even further mentioned about it being even and odd. So now we discuss why this is important. So a function has even multiplicity. This means that it's just going to touch the graph. So you're just going to go touch it and it's going to bounce back up. What we've been dealing with before, what we did in the first graph, was we had odd multiplicity for those graphs. So for those x-intercepts of those graphs. So in those cases, it crossed the graph. So we're either going to sort of bounce off and just touch the x-axis, or we're going to cross through. And it depends on the multiplicity of the intercept. So let's take a look at number one. First, we need to find the end behavior. So we're going to try to graph this x squared times x minus 4 to the fifth times x minus 1 times x plus 2 quantity squared. So the end behavior is given by x squared times x to the fifth times x to the first power, or just x, times x squared, which is, we have to the fifth plus 2 to the seventh plus 1 to the eighth plus 2 to the 10th. So x to the 10th will help us determine end behavior. Now we go and we look at, which looks like this. So the 10th means it's even, and they're both pointing up for our leading term. The x-intercepts, we set the opposite variable equal to 0, which means we have 0 equal to x squared times x minus 4 to the fifth times x minus 1 times x plus 2 quantity squared. And we set each one of these factors equal to 0. X equals 0, x minus 4 equals 0, x minus 1 equals 0, x plus 2 equals 0. So we get x equals 0. That doesn't really change. X equals 4, x equals 1, x equals negative 2. And remember that intercepts are points, so 0, 0. So we look at the x, then the y, so 0, then 0. The x, then the y, so 4, 0. X, then y, 1, 0. X, then y, negative 2, 0. And then all of these have associated multiplicity. So the multiplicity deals with the exponent there. So this is an exponent of 2, so 2 is an even number. So we have even multiplicity. We can just put down even. To the fifth power for this x-intercept is odd. To the first power is also odd. And then negative 2, 0 came from this squared part, so even. So we're going to look at this. And further, we also want to find the y-intercept. However, remember for the y-intercept you set x equal to 0, and do we already have input of 0? We do. The output was also 0. So remember, if you ever get 0, 0 from your x-intercept, that also refers to your y-intercept. Further, when we're talking about multiplicity, those only refer to the x-intercepts. Remember, you can't have more than one y-intercept, so it can't sort of bounce or anything like that. It's always a crossing. So let's label all of these. So we have 0, 0. We have 4, 0. 1, 2, 3, 4. We have 1, 0. We have negative 2, 0. And then, of course, 0, 0 for the x-intercept. I'm now going to switch over to a pencil. So we want, we have an end behavior of them both pointing up. Remember, these arrows don't have to be, we don't have to start there. We're just trying to say, hey, where's the general direction where this graph is coming from? And since this is all we have, so we're going to start, we go from left to right. So we start from the left arrow. Again, we don't have to start exactly from this arrow. we're going to go from here to here, except that usually this would look awkward, so we're just going to say that it's generically pointing up. Okay. Now before I go to this, so this was -2, and it was 0, and this is even. So what's going to happen here is instead of crossing through, it's going to bounce. And remember, we're going from point to point. We're trying to draw a line from point to point. So it bounces, and now it's going to go to this point. Again, the next point going from left to right. And at 0, 0, that's also even, so we're going to, perhaps I should show it kind of bouncing here a little bit better. There should be no sharp points, so it should be smooth, like this. It should be rounded at the tips. And we're going to the next point, which is here. And because the rest of them, so 0, 1, 0, and 4, 0 are odd, so it's going to cross. So it's going to cross here, and now we're trying to go to this next point. Again, it doesn't have to go exactly to that arrow, but we just need to know that it points in that same direction. So this is good enough. All right. Let's try another one. So we have h of x equals -2 times x minus 1 to the 4th times x plus 2 quantity squared times x plus 1. We're going to start by finding the end behavior, which is given by -2, x to the 4th, x plus 2 squared, so times x squared, times x to the 1st, or just x, which gives us -2, x to the 4th, x squared, x multiplied to the 7th, x to the 7th. So we have this. And this means that we have an end behavior that's odd and negative, so it's going to be like this. End behavior leads to x-intercepts. Set y equal to 0, which means we're setting the whole thing equal to 0. So -2 times x minus 1 to the 4th times x plus 2 squared times x plus 1. And then we set each one of these factors. We don't have to worry about with the constant because there's no x there. We don't have to set it equal to 0. We set x minus 1 equal to 0, x plus 2 equal to 0, and x plus 1 equal to 0. Again, also the insides, we don't have to worry about the exponents. So then we add 1. We get subtract 2, so we get x equals -2, subtract 1, x equals -1. Then we write these as points, or as points for our intercepts. So 1, 0, -2, 0, -1, 0. And then note the multiplicity, so even, and odd. We do not have 0, 0 as an x-intercept, so that means we have to manually find the y-intercept. So we plug in x equals 0, and we have h of 0 equals -2 times 0 minus 1 to the 4th, 0 plus 2 squared, 0 plus 1, and we get -2, -1 to the 4th, 2 squared times 1. Times 1 doesn't do anything. -1 to the 4th is 1. 2 to the squared is 4. So we get -8. So when we plug in 0, we get out -8. And these are our intercepts. Along with our end behavior up here, we can start the graph. So in this particular instance, we have 1, 0, -2, 0, and -1, 0. And we also have 0, -8. Now, -1, -2, -3, -4, -5, -6, -7, -8. We now have enough slots down there, and So it should reach all the way down here. And with our in behavior, if we go back and look at it, we know it must start up in this corner and end down in this corner. So start at somewhere here, end somewhere down here. Again, we don't have to start from these arrows, but that's just the general direction from where we start. So we know you're first going kind of from this direction to here. So, and we don't have to start directly from here. And -2, 0 is even, so it's going to bounce here. So bounce, again going from point to point. We're now going to this one, the -1, 0. That's odd. So we then cross through here. And now we're going to have to go to the next point going from left to right. Well, that's actually this point down here. So we're going to have to go all the way down here. And then it should be somewhat smooth. And we have to come all the way back up here. And then at 1, 0, this is even, so it's going to bounce. It'll look something kind of like this. Not, by no means is this perfect, but it gets the idea across. Again, these should be smooth curves, smooth edges there. Something kind of like this. And then it's going to jump back down. Again, it's going to go in this direction. We don't have to go to this arrow. We shouldn't, in fact. It'll look something kind of like this. Again, the final arrow should just kind of be pointing. Remember, you should never have anything that's perfectly vertical or anything that curves back in on itself. Only sort of things to keep in mind for these graphs. All right, we have one more graph that we will try. And this is sort of a last little fact that can further help you with the graphing. If you have a polynomial that has a degree, you can never have more than n-1 turns in the graph. So for example, if we look at this polynomial down here that we're going to try to do, 2x cubed plus x squared minus 8x minus 4, well, this fact that it has its x to the third means that we can never have more than 2 turns. So it can never be more than dupe, something like that. In fact, it doesn't even guarantee that there are 2 turns. It's only that's the most that we can have. All right. So for this polynomial, we need a graph. First thing, in behavior. Well, this one, it's actually easier for the in behavior because it's already multiplied out. So we have 2x cubed, which looks like, so it's a positive odd. So it looks something like that. Positive coefficient times an odd leading exponent. And we get this. Further, we have, we need to find the x-intercepts. So when you're finding the intercepts, remember, it's the opposite variable equal to 0. In this case, the opposite variable is f of x. So we set the whole thing equal to 0. And unlike before, where we had everything completely factored, which was nice, we're going to have to factor this ourselves. We have 1, 2, 3, 4 terms. When you think 4 terms, think factor by grouping. So 2x cubed plus 2x squared, that's one group. Then the other group, you include the negative. There's always a plus between groups. Include the negative into the other group. GCF factor out of 2x squared. And we have 2x squared times x plus 1. And here we can factor, excuse me, that was I wrote this down incorrectly. It should be plus x squared. I was wondering why things were about to come out weird. So this should be x squared times, between 2x cubed plus x squared, we can only pull out an x squared. Again, excuse me about that. And then we have minus 8x minus 4. We can pull out a negative 4. That'll leave us with 2x plus 1. Then we have these two terms, and we can factor out 2x plus 1. And we have x squared minus 4 left over. Then we can factor out the x squared minus 4. It's a difference of squares. And when we do, it's something plus something, then something minus the same something. So square root of x squared gives us x. Square root of 4 gives us 2. So x plus 2 times x minus 2. And then we set each one of these equal to 0, and we solve. We have x equals negative 1/2, which gives us negative 1/2, 0, and this is odd multiplicity. X equals negative 2, and then we have negative 2, 0, which is also odd multiplicity. And then lastly, we have 2x equals 2, which gives us 2, 0, which is also odd multiplicity. So these are our x-intercepts. The y-intercept also has to be computed manually, but when it's in this form, the y-intercept is also actually pretty easy because you're plugging in 0, and you have all these terms that are going to have 0 plugged in for them. And this goes away, this goes away, this goes away because you're multiplying by 0 in each of those cases, so you're just left with negative 4. So a lot of times if you actually have it written out as a polynomial, whatever the last term without a variable is should be the y-coordinate of your y-intercept, which is actually kind of nice. So we have 0, negative 4 for our y-intercept. All right, so with this being said, we have negative 2, 0. We have 2, 0. And then we have negative 1/2, 0. So here, oh, oops, sorry. So negative 2, 0, negative 1/2, 0, and then 2, 0. Further, we also have 0, negative 4. And then it's just, we also now need, so we're going to switch over to a pencil. The end behavior was, again, it was 2x cubed. So it was odd, positive, odd, which gave us this. So just the general direction of where we need to start and end. So we go from left to right, and that means we start from the direction of the left arrow. So again, we don't start directly from there. Usually these things are steeper, but it's going to start going down, and this is our first point. So, and all of these are going to cross because they're all odd. This is a reasonable guess for this particular graph. That concludes this section.